The blank was heated in sections and reduced in width using a treadle hammer. Appropriate PPE was worn at all times. A rolling mill was used to straighten the blank between passes. Once reduced enough, a hydraulic press was used to reduce the width further. A tip was then hand-hammered into the blank. Bevels were hammered into the sides, reducing necessary grinding and adding curvature. The blank was heated and cooled multiple times to relieve internal stresses. Excess material underwent the same heat treatments and was used for characterization. The blade edge and spine were ground to shape, establishing the final blade profile. A surface grinding setup was used to create parallel surfaces and then add a distal taper. The blade undergoes 2 more normalization cycles before heating to temp and quenching into AAA quench oil. To reduce warpage, the blade is pressed between 2 aluminum plates. We still wound up with warpage, so after temper the blade is heated and bent to remove the warps. The bevels are ground in, initially using a guide, and then finished up freehand. A pattern was traced from the guard of an old cavalry sword, then 3D printed using PLA filament to find an accurate size and shape for the guard. A heat gun was used to shape the PLA onto the tank. Steel guards with the same dimensions as the PLA prints were cut out using a water jet. One of these guards would later be nickel-plated. Using a 3D builder, we printed a handle out of wood-fill PLA. The handle was then sanded and burned using a heat gun to give the look and texture of a wooden handle. The tang of the blade was ground to its final shape, and a dry fit of the hilt was performed. Copper accents and a copper pommel were fabricated. As a final touch, the Texas A&M and Reveille logos were etched onto the blade.